Aloha, this is ITS128, and today is September 24th, and we're going to have probably a little bit shorter class today because October, what did I say? September 24th. That would be 9. Okay, so we are finishing up. Oh, yeah, I think we've only, last Tuesday we did these 4 Xylabs exercises, and so today I think we're just going to do 15 and 16, and then next week we can start on chapter 5. Chapter 5 is going to be a longer chapter. I'm sorry, I'm not sharing my screen. Am I? Not sure. Okay. All right, sorry. Okay, so last Tuesday we did exercises 4, 11, 12, 13, and 14, and they're posted. You can click right here on class number 9 and see those. And so today I think I'm just going to finish up 4:15 and 4:16, and then next week we can start on chapter 5. And we might chapter 5. I think chapter 5 and 6 are going to be pretty long chapters, and they're pretty important. So maybe we'll spend a little bit more time on those. Okay, so we're in. Let me just go here, chapter 4, and we're gonna look at these 2 examples, or these 2 lab exercises here. First one is 4:15. Let me see if I can play this.
What does it mean, exact change?
Well, when you think about it, exact change is kind of a weird concept, but what it is, of course, is when you're given a certain amount of, when you have to pay for something, if you have to pay with exact change, then you have to give the dollars, quarters, dimes, nickels, and pennies, so it all adds up exactly to the amount that you owe. So, and so with this program, you are going to be, you're going to enter in you enter in an amount, and it returns how many dollars, quarters, dimes, nickels, and pennies it takes to make up that amount. So basically what we do is we take the amount, and then we first divide out the dollars, and that's simply a mod 100. And then after that, we divide out the quarters, and that's a mod 25. And then we divide out the dimes, divide out the nickels, and what's left is the pennies. So let's see. We can start by type your code. Okay, so the first thing we have to do is read in this amount, the amount, so we can do input value equals int, it's an integer input, and I'm going to enter amount. And I'm going to do that, but you probably aren't going to, don't need to do that to get it correct. But I like prompts. Okay, now the first thing we should check to make sure that it's greater than 0. If it's less than or equal to 0, there's no change. So if input value is less than or equal to 0, then you can just say print no change. Otherwise, we first let's divide out all the dollars. So we say let's create a variable num dollars equals the input value integer divide 100. So that means if we enter 450, we integer divide by 100 and we get 4. So 4 is the integer value, but then there's a remainder of 50. So the number of dollars is going to be the input value integer divide 100, and then what is left over, let's call that input value again. What's left over is the number of dollars. Oh no, it's the old input value minus the number of dollars times 100. So so for example, if we entered in $4.50, this is the number of dollars is 4, and 4 times 100 is 400. So 450 minus 400 leaves 50, and that's what we want. Let's see, there must be another way to do this. How about if we do input value mod 100? Yeah, that should work. I think that'll work too. All right, I'm not sure that'll work, but let's. Okay, so that's the number of dollars. So what's left over is the cents, and so now let's divide out the number of quarters. So I'm going to say num quarters equals input value integer divide 25. And then I think I can still go input value equals input value mod 25. I should actually be able to just do this. Mod equals 25. That's the same thing. And so now now let's do dimes. Num dimes equals input value divided by 10, and input value, the new input value, mod equals 10. And then we do the number of nickels. Num nickels equals input value divided by 5. And input value mod equals 5. Excuse me, let me open up my chat in case anybody wants to chat. And then I guess what's left over is pennies. Yeah, it's pennies. Num pennies equals input value. Now, what I'm gonna do is I'm gonna say I'm gonna print out intermediate values just so I see what's going on here. Okay, so I'm gonna say print dollars. I'm gonna print num dollars and then input value, because I want to see what those intermediate values are. I tell you what, I'm going to switch over to. My local stuff here, and I need to bring up a command prompt. CD, no, not CD desktop, and Python. Save this. Oh, all right. In print uh, input value, comma, starting input value. Okay. All right, let's see what this just looks like. Save this, run it, Python test.py, indenting, what doesn't it like? I think it's something's messed up here. So I'm gonna copy all this stuff. I'm gonna go Shift Tab and then Tab. What happened here? Tab. Is this a tab? Tab. All right. Does this work? Enter amount. Okay. How about let's see, $1. Let's see, $1 and 60, 70. $1 and 64 cents. 164. Okay, 60. So it's $1. Oh, no, darn it. Num dollars, num quarters, num dimes, and num nickels, and num pennies. Input value. I think this is going to just be. I've never done this before. I wonder what something mod 1 is. I wonder what this is going to be. Anyway, let's see what this is. Let's try 164 again. Okay, we had $1 and 2 quarters. That's $1.50. 14 cents left over. One more dime. That's $1. Okay. That's $1.60 and 4 nickels. 4 cents is left over. No nickels and 4 pennies. Okay. So what's 169? 169. So it's 169. First we get $1 and the leftover was 69 cents, and we take 69 cents and we try to divide it by we take mod 25. That's going to be 2, and what's going to be left over is 19. And we take 19 and we take that divided by 10 to see the number of dimes, and it's going to be 1 dime, and what's left over is 9 cents. And that equals 1 nickel, and what's left over is 4 cents, and that's going to be 4 pennies, and what's left over is no cents. Nonsense. Okay, so that's great. What's missing is you need to, if it's, well, let's see, how are you supposed to print this out anyway? Quarter, oh, you're supposed to print out like that. So it should look something like, Okay. Num dollars, and not this. Oh, it's if num dollars is greater than 0, then you do that. Yeah. You can just do it this way though. If, and then you want this. Well, this is what you want it to look like. So let's just copy this. Put this here. I'm just going to do this here, 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 and here. And this is num quarters. And this is num dimes. And this is num nickels. And this is num pennies. Now the problem is I'm going to do $5.69. $5, 2 quarters, 2 dimes, 1 nickel, and 4 pennies. The trouble is this should not print out 1 dimes. It should print out 1 dime, 1 nickel, not nickels. It's a plural thing. Darn dang plural thing messes you up all the time. So you should rather do something like if the number of dimes is equal to 1, then we gotta do this now. Dime. Otherwise, if num dimes is greater than 1, then you say print num dimes, comma, dimes. Okay? $5.69. There we go. Look at that. 1 dime. And if there's not 1, you want to make sure it prints what's $5.59. It doesn't print anything about dimes. All right, well, anyway, you can fix this because it's not completely fixed. All right, so that concludes 4-4.15. All right, so what's the next one? I'm going to get rid of this. Okay. Leave. All right, so now let's do this leap year thing. Okay, with this one, a year in the modern Gregorian calendar consists of 365 days. In reality, the Earth takes longer to rotate around the sun. You know, the calendar is supposed to be like, so the Earth rotates around the sun and it's back at the same spot January 1st of every year. But the Earth actually takes a little bit longer. So every 4 years, we have to add a year to the calendar, add a day to the calendar. And that's where leap year comes along. So to account for the difference in time, every 4 years, a leap year takes place. A leap year is when a year has 366 days. And so it's added in February, of course. And so when do you add a leap year? Well, um, if the year, okay, if it's divisible by 400, then it is a leap year. If it is divisible by 100, it is not a leap year. No, if it's not divisible by 400, but it's divisible by 100, it's not a leap year. Otherwise, if it's divisible by 4, then it is a leap year. Otherwise, it's not a leap year. You got that? So if it's divisible by 400 and it's divisible by 100, then it's going to be divisible by 4. So instead, you can look at it this way, where first we test to see if it's divisible by 4, and if it's not divisible by 4, then we're already done. We know that it's not a leap year. If it is divisible by 4, we have to do some more checking. So the first thing we check is it divisible by just 100? If it is, then it cannot be, no. If it's divisible by 100, then it has to be divisible by 400 for it to be a leap year. So there's a bunch of different ways that we can write this. Let's so the way the code is it starts out with a variable called isLeapYear, and then we do some stuff, and at the end we're going to print out if leap year is false, we're going to say not a leap year. If it's true, we're just going to say it is a leap year if it gets switched to true. So I'm going to start with this, and I'm going to go over here and do it. Okay, so the first thing, if false. Okay, if input year is divisible by 4, then we're going to do something. If it's divisible by 4, let's see if it's divisible by 400. If input year is divisible by 400, then it is a leap year. If it's divisible by 100, and I'll just do this. If it's divisible by 100, then if it's divisible is divisible by 400, if it's divisible by 400, then it's a leap year. Leap year, well, is leap year equals true. It's got to be capital T. Don't put quotes around it either. Otherwise, else is leap year is true. I don't know. This might be all that we need. And I'm going to print. I'm sure you who just texted. I'm sure yours is correct also. I'm going to try this way. There's lots of different ways. We can try yours afterwards. Very good. Okay. So I'm going to say we have to print out this input year, and equals input year. If if leap year, yeah, I guess I can't be any more fancy than this. If is leap year, if is leap year, then print is a leap year. You got to do it the way it says. Something like this, though. Else print is not a leap year. Okay, I'm going to see if this works. Oh, I don't have a prompt. Oh well. 1792 is not a leap year. Isn't 1792 a leap? No, it's not a leap year. 1792 is not. Okay, 1712 is 17. Okay, I'm going to put in a prompt. Enter a year. Enter a year. (1712) is not a leap year. 1712 is a leap year, isn't it? Okay, so my logic is wrong, isn't it? Is a leap year. Okay, let's see how wrong it is. 1913. Whoa! I bet you my logic is just opposite. Maybe it's just opposite. Is leap year? No. False. Okay, so 1913, this would be, ends up being, it skips, it's not, oh, wait a minute. Oh, wait a minute. No, these if statements are all corny and wrong. Equals 0. Sorry, I don't need to put parentheses around my if statements, do I, in this language? I just need to go, is it equals 0? Yeah, stupid. That's how you test if it's. All right, let's try this now. (1913), okay. 1712, okay. 1900. Is that a leap year? Not a leap year, right? But 2000 was a leap year, wasn't it? I remember when I grew up, I learned the rule all the way up to if it's divisible by 100, it's not a leap year. So I learned that when I was really young, and then when it was coming up towards the year 2000, I was looking forward to it not being a leap year, and then before then I learned that I was wrong there. But anyway, so it's like you don't even need this 400 rule, do you, in our time? All right. Well, anyway, so that's one way to do it. So there's lots of different ways to do it. And all you got to do is make sure that it works here. All right, so anyway, I don't really have too much more than that for today. We're finished with chapter 4. Does anybody have any questions? Okay, well, I will end this video and post it up, and next Tuesday we'll start with chapter 5. All right?
Excuse me.
Yes.
Sorry, I just want to know, is it normal to feel confused at this point? I feel that I don't understand some of these, problems. So is it normal, really?
You know, it takes a little while for it to click. But what sorts of things do you like? Okay. Is there something that I could do to help you understand more? Should I go over more examples or something?
I don't know. You like the last one that you just put
Yes.
talk about it. I was reading the whole things over and over, and I think I don't get it. What they want. I mean, I have to go back to like at the beginning of the book and just read again and again and again to find the answer. So is it me only, or like?
You know, the way I kind of teach is I kind of show you how to get the right answer, and then if you kind of get the right answer enough times, you sort of pick up what's going on. I can do a better job of explaining my logic as I'm going along, and I think that's really the thing. Maybe I should spend more time with this whiteboard thing here, this whiteboard, and draw pictures. Does that help? Sometimes when I draw pictures, or have I done that in this class? Maybe I haven't. Oh, I guess I haven't. All right. Why don't I spend? I tell you what. Since we're kind of early, we're kind of getting ahead. Why don't on Tuesday? Why don't I review? And I'll go over some of these problems. And in fact, if you would like to email me, or if anybody would like to email me problems that they got right because they followed what I did, but it didn't really click. You don't feel comfortable that it being something you could have come up with on your own without a lot of help. Maybe you could tell me what those problems are, and then I can try to explain it in a much more basic way. And I can start by making a flow chart. And then sort of we can see the logic. I tried.
It would be great.
Pardon?
I say it would be great.
Okay. Good. Let's do that. We are, we're kind of moving right along. I'm pretty pleased with the way this textbook works, and I've been reading. I may have mentioned this in this class. I've been reading more about this approach of this, where you go through all these little activity exercises, and you do these small problems, and in theory it's supposed to be a much easier way, a much less stressful way of learning how to code. And so I'd like to see it work. I like less stress, and so next Tuesday, if you could send me the ones that you found difficult, and I will go through and look and find ones that seem like they might be a little bit more complicated, and I can go over those also if we have time afterwards.
Thank you.
All right. Okay. Great. So have a good weekend, and I'll see you on Tuesday.
Thanks. Bye.
Bye.
Thank you.